Question number 26. In this question, a vector is given to be equal to 0.5 I cap plus 0.8 j cap plus ck cap, and we have to find out the value of c. It is given that a is a unit vector. This means that the magnitude of a, which is 0.5 square plus 0.8 square plus c square, will be equal to 1, or c square will be equal to 1 minus 0.25 minus 0.64. We can also write down that c will be equal to under root of 0.11. And hence for this question the correct answer is option number 3. Now let us move to the question number 27. In this question it is given that the magnitude of the vector product of a and b, that is mod of a cross b, is equal to, that is, root 3 times multiplied by a dot b. We can write down therefore that ab sine theta, as this is the vector product, is equal to root 3 ab cos theta, giving us a value that tan theta is equal to root 3, or theta is equal to pi by 3, or 60 degrees. And hence for this question the correct answer turns out to be, dear student, option number 3. Now let us move to the question number 28. In question 28, if the length of the spoke of a wheel is 30 cm from the axis of rotation, then we have to find out the acceleration of the point of the tip of the spoke if the wheel is rotating at 120 rpm. So dear student, first of all let us convert 120 rpm to radian per second. That will be 120 into 2 pi by 60, that is 4 pi radian per second. The required acceleration will be equal to omega square r, where omega is the angular speed and r is the radius. So this will be 4 pi square into 13 to 10 raised to power minus 2 meters, as the distance is 30 centimeters. This will be equal to approximately 47.4 meter per second square, giving us a value that matches with option number 2, which is our correct answer. Now let us solve the question number 29. In this question the position of a particle is given as a cos omega t I cap plus a sin omega t j cap. R is the position vector and t is the time. Then we have to find out whether the velocity is directed towards the origin, away from the origin, parallel to the position vector, or perpendicular to the position vector. The student, velocity can be written as the differentiation of position, and that will be equal to a omega multiplied by minus sin omega t I cap plus cos omega t j cap. Herein the value of r dot v will be equal to a omega square minus cos omega t sin omega t plus sin omega t cos omega t, and this will be, dear student, equal to 0. This means that the velocity and position are perpendicular to each other, and hence we can clearly write that option number 4 for this question is the correct answer. Now let us solve the question number 30. In this question, in uniform circular motion, both velocity and acceleration are constant, or we have to find out whether one of them is constant or other is variable. Dear student, in a uniform circular motion, let this be the circular path, the velocity is always tangential, and hence the direction of the velocity changes at every instant. However, the magnitude of the velocity remains constant. This means that velocity is a variable. Also, the centripetal acceleration is always directed toward the center. It has a constant magnitude equal to v square by r. However, the acceleration is also variable. Therefore, we can write down that acceleration and velocity both are variable and they both change. And hence, for this question, the correct answer should be option number 3. Now let us solve the question number 31.